3, 2, 1.
All right, ready? Hey everybody, we're here on Sparkfun Live. I'm Casey.
I'm Pamela.
And today we're gonna attempt to build a GPS speedometer. So yeah, to get right down to it. GPS receivers, we're gonna use one of these little guys. And they spit out latitude, longitude, but they also spit out direction, heading, and velocity. So we're going to use the velocity measurement from a GPS receiver and print it on a small little LCD screen that we have here, a little 7-segment LED. Yeah, so some of the pieces you're going to need. We have a wish list. I believe it's in the comments. So we have a down there. We have a wish list with all our pieces and parts. So you're going to need our serial 7-segment display. It's actually got a little microcontroller in the back. I think there was a question of that earlier on. You're going to need our GPS receiver. A handful of buttons. We put some suggested colors in the box, but you can use whatever you like. A nice little buzzer. So we got a little buzzer that's going to tell you if you're going too fast or too slow, or you can hack it to do whatever you want.
You'll also need a LiPo battery and some breakaway headers.
And then, yeah. Oh.
Some wire to connect everything together, a soldering iron.
Yeah, and then lastly, just we got a little JST that connects to the GPS. So, so to start this, because I am so prepared, there is no schematic right now. So this is the one and only working GPS speedometer in Northwest Boulder. So we're doing it live, guys.
It's intense. It's a lot of pressure.
Yeah. So to start out, a cool thing that we're trying to do with this, and I think Mike's trying to get us a camera eventually, so we can show you the details. So we're actually using the jumper wires as connection points. So rather than soldering things directly point to point and making everything permanent, what we're doing is we're trying to use these jumper wires to make almost header connections. So if you want to unplug things, you can do that. You can switch things around, but it also makes installation a lot simpler. So first thing is we'll go ahead and get our buttons started. So each button will have, let's see what we got, 2 wires coming off of it, and they are both. So what I typically do is for a button, it doesn't really, polarity doesn't matter, but I try to just kind of keep it consistent. But what I'll do is I'll use one cable for one button. So you'll have kind of a male and a female connection for each button. This is really handy for when you use things like batteries. So we have a little battery charger that we're gonna use, and by having a kind of a male and female end, there's kind of a chance you could short it, but it also helps when you plug into your device. It keeps you from reverse polarity and kind of protects you from yourself. So yeah, so we'll go ahead and start cutting these apart. So if you want to, so what I've done is for the red button, yeah, I do a red wire, and then for the green button, I'll do a green wire. And then what I'll do is, so we're gonna have kind of this, it's kind of a mess.
Slightly a mess.
Yeah.
Just slightly.
So we have a bunch of wires that are going to this ground. My prototype actually is not using a power switch. That's because when it was actually built, I built it for my, I have a really old car and the speedometer only marginally works. So it was kind of actually like a helping thing for me to put in my car and let me know if I'm how fast I'm going, because the speedometer needle actually spins in it now. So it's really great piece of machinery from the 70s. So, but we're going to use the power switch, and I'm going to go ahead and start maybe cutting some wires to get everything ready.
And like for all Sparkfun lives, you can always ask questions either in the comments, in the blog post comments. We also have chat, and I will make sure to ask those questions to Casey or myself, or answer them.
I can't. All right. I love that we're figuring this out live. It's the best way to test.
This is my first time actually seeing the inside of this. So schematics normally help, fritzing diagrams normally help, but this is Casey. So.
Yep. All right, so for ground wires, I'm just going to create a bunch of them all at once. I'm just going to use all the same polarity, so that essentially there's just a common ground for the entire system. So actually, yeah. So we'll do, so I'll strip these as quick as I can. I need, how many grounds do I need? 1, 2, 3, 4, 5. I got it right. So to also, further throw more elements of danger, we have a 3D print going. The enclosure for this is being printed live. So yeah, hopefully that works. But I'm actually pretty confident this is the Lulzbot Mini, and we've been using it for the last couple months, and we have a whole bunch of little pieces and parts we'll talk about through the show. Yeah, it's a great little printer. If you just want something that's just kind of set and forget, hopefully I'm setting it, and hopefully it'll just keep going. So I'm gonna go ahead and start tinning wires. I made a mess already. Probably have flat. Oh, they're nice and fogged.
And on the table, we also have examples of other things that you can 3D print, like this turtle, so movable things. Put him over here.
Okay, so first thing I'm going to do is I have a bunch of ground connections ready. And what I'm going to do is I like to bring everything to a common ground. So I'm going to use the switch as my common ground. So this switch, guess what? I cheated. I have the turkey in the oven. So this is exactly what we're printing over here. And so this switch will pop right in, like so, which is awesome. But what I'm going to do is I'm going to bring all my ground points to this switch. So the idea is when I flip this switch and open up the circuit, essentially what I'm doing is I'm removing the negative terminal of the battery from the circuit, and yeah, keeps it really nice. So to make this fit, this is I believe this is a through-hole switch. It's meant to be soldered to a circuit board, but since we're putting it in an enclosure, what I'm actually going to do is I'm just going to take these little legs off, and I just need these little pads, and I'm just going to kind of solder something to them. So
Casey, why do you need a common ground?
Why do I need a common ground? Well, this, yeah, I guess a common ground is great. It's especially great when you're working with multiple voltages. So it's easier to have one switch to lift the ground. So if you had 2 batteries for a system, you had like a 12 volt and a 7 volt, you can bring all of the grounds together. So you have one common reference and you have one switch that turns everything off. If you had, if you switched on the positive side, you would switch your 12 volt and your 3 volts or whatever other voltages you had. So, yeah, that's my, thank you.
Very soft clap.
They won't fire me today. So cool. Actually, if you want to solder that, just however, a good thing to have is heat shrink. We're not using heat shrink because it's live. So, but you can use heat shrink if you want to actually keep this in your car, or if you want to give it to a friend or something, or just make it look a little better. But because we're doing it live, we're gonna cut every corner. So, while Pamela's working on that, I am gonna slowly figure out the buttons. So these little momentary buttons, you just push them, and essentially, let me see if I can, there was one of these that was a little loose. I kind of wanted to show you the inside of one of these. Kind of cool. And they're very simple. So if I disintegrate one, like I just did, I don't know if we can get a close-up, but let's see how this works. Anybody? You want to try? All right, let's see. Maybe you can see inside there. Maybe we just don't have quite enough light. But so what we have here is, this is the plunger. So you push on that little guy, but it's dead because I killed it. But you would push there. And of course there's a little spring. The little spring is what pushes it back. But the simplicity of the switch is that in this little housing here, there's 2 little terminals. And essentially on the inside of the switch, those terminals just, let's see, maybe, yeah, there we go. You can kind of see both of those little pieces. Those are just in there. And then the switch itself has this little like cup looking thing. If I kind of wiggle it around, you can kind of see that. And really the switch is so simple that it just makes contact. So it's great for digital logic. If you've ever heard of debounce circuits though, this is the switch that these were designed for, because these are pretty cheap. So you may have issues, but for our circuits, it's great. So thank you for your service. So got that on there?
Yes.
All right, yeah.
So you can see that I soldered all of these wires on, so you should have on one side actually 5 wires coming out with the male headers on the side, all connected to the same ground.
Okay, so to continue on, so I kind of like to build circuits power first. I'm a firm believer that anytime you have a problem with a board, usually it's a power issue first. So I like to kind of build out my power system and then slowly add the digital logic to it. So that'll go on the other side. It does look like a really small wire, but we're using such little current that it's not a big deal. So that wire is essentially our common ground, and then what we'll do is we'll have another one of these that we will cut and strip. And this will go to the negative terminal of the battery. So we're slowly building up our circuit with the switch from all the components into the battery. So this is our single cell LiPo charger, and it's a really cool little chip. It uses just a USB, so you just plug it in your USB port, and I believe this one charges, I think by default, at 100 milliamps. We can pull up a data sheet here soon, but it charges at a default of 100 milliamps, or you can set it to 500. But a little handy little thing to have. It's got a nice little hole that you can either screw it into a project, or I actually use it for glue. It's actually kind of great because you can kind of hot glue to the base and then up through the hole and press it down kind of like a glue rivet. So, but I'll show you how that works here when we get it all installed. So,
Just double checking.
yep. And then this will go onto the negative terminal of that.
Okay, perfect.
So, so now continuing to debug the mysteries of this.
Casey, we had a question from the audience.
Yeah?
They want to know what the story is with your shirt.
The story of my shirt. Oh man.
Not to totally throw you off.
So yeah. So I forgot I had this on. So I was part in college of a rocket team, and what we did was we built sounding rockets for it was a place called Walp's Flight Facility, and we built a robot. I built robots. Built a rocket that went it was about 100 miles up. And so one of the team requirements was you had to have shirts so that they knew which payload you were with. And we just kind of saw these shirts and said, hey, let's do it. But we put our names on them so that they could also yell at us. Because we had like these super small name tags. So, but yeah, that's that. Thanks. Let's see. So luckily power for the system is really easy. So since the 7-segment display is essentially going to be what's going to be powering all the buttons, going to be powering the buzzer, the GPS. We really just need to have 2 power connections, and so I'll get started on those. So now, if you're trying to make this more permanent, of course you don't have to use this kind of technique of using jumper wires. I do it because it's kind of nice that I can unplug things around and move things around a little easier, especially if I gotta do testing. If you run everything with male ends, if you start running into really big problems, you can always pull everything out and start connecting into breadboard. So if you want to add extra components, you can do that. So, but let's see, you have that. So if you can put this on the positive end.
Awesome.
And so we have a bunch of different types of these little 7-segment displays. I don't know which colors are which. I think this one's a white one, and I think this one might be a blue one. But the colors, pick whatever you want. For my car, I went with green. I have a thing for green. So if you've seen my car, it's almost hideously green. So, but yeah. So let's try the white one. So put this on the side for now. So let's see if I can pull up on the computer. Oh, so actually, so I got Cura for printing. I'll scoot that to the side. So this is our model that we're printing right now. You can see Cura. You can preview what you're building, and it'll give you a little estimator up here at the top for how long it's going to take to print, and how much material we're going to use and how heavy it'll be. But Cura's awesome. Like, all I have to do is drag the part in and then just go for it. So hit print.
Where do you find your parts?
Where do I find my parts? So I've used Thingiverse. I don't know. Have you done much? No? But Thingiverse is the best one I know. A lot of the stuff I do, I just draw the parts. I think we have a SolidWorks license on site. There's a whole bunch of programs. Blender's another big one.
100% open source too.
Yeah, I'm a bad one.
3D printing is just got super popular. You can literally type in, I want to print left shark, and there's going to be, you could actually get that off of Thingiverse.
So on my computer, I've got the 7-segment display. It's got it can bring up a much better picture of what's going on the backside. So as far as power, so we have this, I don't know if my mouse is visible, but we have this little VCC, so that's power in. This device should work on 5 volts or 3 volts. Since we're using 3 volts, a lithium battery is more than okay. And of course we have our ground connection. But over here, what's kind of cool is there's an FTDI header. So we're actually going to reprogram the default program that's on there with something that actually runs the GPS. So, but yeah, and then to connect the FTDI, you want to do that?
Yes.
Because this is not easy. This is not easy. So it's kind of strange. We've looked at it. We probably might look at a redesign, but I don't know if we can see that. So the headers here are very close to the edge of the board, but there is the 7-segment display. I think Pamela's got a really good shot. So she's gonna put the little headers on there. But since you can't push the headers all the way through, you're actually gonna try and solder these kind of from the top side. So the little plastic bit that holds the headers together may get just a little bit melty, but you know, it'll work. That's why we made an enclosure. Enclosures are great because you can take your rat's nest of a project and show it to your mother and she'll still think that you're great. So.
Speaking of messes,
Oh yeah?
the audience wants to know how messy your office is.
It is a disaster. It is an absolute disaster, and it just gets worse. I just got a new shelf. Yeah.
Slight improvement. It's pretty good.
Slight. So
that means you can have more stuff in the office, right?
Yeah. I'm sure there's got to be photos somewhere of my office online. It's awful. So. But I don't know. I always have the phrase, there's beauty in chaos, right? Huh? So,
Yeah.
sure. So, this wire. So, thank you so much for helping.
No problem.
Because I would probably still be sitting here with a pile of wires going, what am I doing? So,
were you able to guess Casey's office is super messy due to this table? The way that we have everything organized? We just have a random drill that's just kind of...
we're going to
sitting
need
here.
that. We're going to need the drill.
Sorry, guys. Sorry.
I have a system.
You have a system.
So, I should probably do better. But yeah, these little jumper wires, they're handy for everything. I think another engineer here, Mike Ford, he just has like a bucket full of them and just uses them for everything. So they're just handy. So, so while Pamela's getting that going, actually we should try to go straight so it'll fit in the enclosure.
Okay.
You see this? So it'll fit in there. Burp, burp. It'll come off. Or do you want just another one? Here.
Yeah.
Whoop, that didn't happen. So, so I have this little JST connector. This is something we sell on Storefront to go with our little mini GPS receiver. And it's kind of cool, so you can disconnect it. It's actually going to be important that we can disconnect this GPS when we program, because for our program, we're going to be using the same port that you would upload code to read the GPS. Taking a look at the data sheet. So if I'm on my computer now, the little GPS 50-channel receiver. Go down here to the data sheet, which we have, and I actually have it in another tab, so I'll bring it up here. And so what's cool is it gives you all the specifications, the size, the dimensions. So the dimension was actually great with my CAD program to design the enclosure so it actually fit. But we have, more importantly, the pin assignments. So it's a little unusual from other pins. Usually pins go left to right. For some reason this one goes right to left. I don't know why. But the pins that we're going to need for this are obviously going to be pin 1, which is ground, pin 2, which is VCC, that's our power, and luckily this little GPS receiver will operate, from 4 to 5 volts. A good LiPo battery will actually run this. So I know we're running kind of low on the low end, but it's been great. Actually, no, I lied. I'm looking at the USB interface one. Look at that. Down here, 3.3 to 5. I was kind of like, what? So anyways, all right, enough of that. So ground power, and then we have TX and RX. So thankfully, this data sheet has said, so TXA is serial data output, in quotes, from GPS. There's always that mystery of like, is it transmitting, is it the transmit receive side or transmit out side? So they cleared it up for us. So really all you need are the first 3 wires of the connector. So we can cut these extra 3 off. Because the next one is received to the GPS. So there's some ways that you can actually configure this, but for our application, the default settings are great. So now VBAT, this little pin, if you want to throw a coin cell on it, that'll help you get a GPS lock much faster. This receiver takes a little while. It takes about 5 minutes. I don't know if you've had better luck with other receivers.
5 minutes is pretty good.
So 5 minutes for a lock, but if it loses lock, it usually comes back, within 30 seconds. So, and then there's a power control pin, which we're not going to use that either. So what I'm going to do is I'm going to go ahead and cut all these. Make this nice and try not to destroy it. So, and if you need little wires, it's got, I don't know. Sometimes people keep these, they're handy. And that's that. So let's see where we got. So we have that. So Pamela soldered the headers on. And yeah, the trick is to keep it straight or even bent in a little bit so that you can fit, after you're finished assembling the FTDI. It's actually not going to stay with the project. So if you bought one on the wish list, you now have one for other projects. So, yeah.
For those who don't know, what is the FTDI basic, Casey?
Oh, pop quiz. Where is it? It's somewhere. So, you have it.
Yeah, I'm pulling it up.
Oh.
I'm trying to be the co-host and ask you questions.
I don't know what I'm doing. FTDI Basic, it's just a little, it's a USB to serial UART bridge. That's
perfect.
That's a great answer. So it's essentially like if you get a Redboard or an Arduino, a Redboard has one built into it. A Pro Mini is essentially like a Redboard split in half. So, but much smaller. So, yeah. Great. So, let's see. So for this, what we're gonna do is, so you have power, ground, and data. So,
Power, ground, data.
Yeah. So if we cut, so in mine, I did it terribly. But what we're going to do is we're actually going to, since this is a cable connection, we'll go ahead and just solder this straight to this board.
Okay.
But if you can also, like this is where it's going to get tricky. I'll show you this. So wherever you put the power, twist these two together. So then we can bring power from our battery. So, and then here is this little guy too. So I just use that power.
Okay.
And then the ground, what did I do for the ground? So you'll need another ground wire. So here's a ground. Now is when things get crazy.
Do you have suggestions on cable management?
Hot glue. It's actually ready. Oh, that's a rough one. Cable management. That is.
Do we really want to be asking us about cable management?
I swear, at one
Just
time
joking.
I did all right. Nope. So let's see. So we're almost there. So the buzzer, a cool little thing of the buzzer is the jumper wires. Actually, will just snap right onto the legs, so we don't have to do anything really fancy with that. The buttons don't have polarity, but the jumper or the speaker actually does. And we'll see if I can, maybe we can zoom enhance. If that doesn't work, let's see if we pull one up online. Because we have pictures all over our website. Maybe? There we go. So there's actually a little, there we go. On my computer I got a nice picture of it. So on the back of the speaker, there's little polarity markers. There's a negative and a positive that we can work with. So, are we good? Oh. So, but anyway, so you can see the little positive, negative polarity markers for the speaker. And so that's about the only thing you really need to really maintain. So, but cool.
Casey, do you want me to start soldering these to the board?
Sure. Yeah, if you can. Yep. And then I will keep this. This is ready. I'll go ahead and solder up all the buttons. That should go by pretty quick. So everybody around the building is freshly tired, or maybe we've all taken our comp day from ABC. Mike, who's running our Sparkfun Live right now, was the mastermind behind the stream, which was awesome. And this year we had 2 streams, so we had the ground and the combat. So yeah, you were a judge.
Yep. Judge for the ground. We should have a video of ABC recap video coming up soon.
Nick. No.
Yeah, as we stare at our videographer. Okay. For those who didn't hear, Nick said that they're hoping for tomorrow we're going to showcase the ABC recap video.
That's pretty much a contract.
Yeah, you heard it here.
So, I don't know if maybe this is a good time to break a little bit, but we while we were testing this, in the promo video you saw, Hackster.io came out to ABC to show off some stuff, and they brought their DeLorean with them, and they actually dropped it off. It was like a week early. I think it was like a week early, and it just showed up. And so, of course, the first question everybody asked was, "Can we drive it?" So Sean upstairs asked. I think he tweeted at them, "Can we drive the DeLorean?" And Hackster was like, "Yeah, that's cool." And we all said that's your biggest mistake. So, but we did a little video, crammed Nick in the back of a DeLorean, and tried to show this thing working. Sure. Roll it. You're a human pretzel. Yeah, and he didn't say a single word. No.
There's another segue. Folks are asking if there's going to be video of the BattleBots competitions.
Yeah, I believe Greg is just slowly chewing through hours and hours and hours of footage. Yeah, I mean, you guys had tons of footage as well. How many cameras did you have on the?
That's a great question. Mike, do you know how many camera people there were?
Yeah.
So we had about a crew of 5 people who was walking around with different cameras. So we could have tons and tons of footage of everything.
So the streams should be, I believe they're on the website. I think if you want to go through the raw footage, it is up there. But the footage that Greg is going through is we actually stuck 2 GoPros to the inside of the arena, and so he's going through. Actually, no, 3. We had 3 arena cameras. So he's going through all that footage and putting together kind of a greatest hits. And I'm trying to beg of him to release all the footage in some fashion. So, but a lot of great competitors. So now I have the buttons ready. So I have these. They're essentially like little pigtails. I'll show you one of them. So there's going to be a little positive. This will be the coming from the microcontroller, and then this end will go to a ground. And when we get into the code, I'll show you all how we're going to use the microcontroller to provide an internal pull-up, and we'll go over that. So, but these are ready. Man, is our box almost? How's it cooking? So.
For a box this small, how long do you think it would take on the little spot?
So, to ensure that they would actually be done, I started this about 20 minutes before the show started, and I want to say that, so Kira has an estimator on how long things should take. It says that this one should be 1 hour and 31 minutes. Sometimes Kira doesn't account for. I'm told that there's a bug that doesn't account for the rapid transitions. So it's usually, they say, between like 5-10% longer.
Nice.
So, but hopefully it'll be done by the end of the show, or I'll have to use the backup. So I'm probably going to use the backup.
So not that long ago, you did a blog post about silly things and useless things you can put on a 3D printer. What was some of your favorite useless things?
Oh, there was, for starters, we did get one of them printed.
Oh.
So there, a climbing carabiner, because that's good. I don't know. I saw a lot of good ones. There was someone put paper, which I thought was I was like, that's dumb. And then you figure well, what if you wanted to make a paper airplane and you have a sheet of plastic? I don't know. What was your favorite?
I like the socks. I thought that was creative and useless. That was my top useless thing.
Could you even make a pair of, like,
No.
does Thingiverse have socks?
I could take a look. They probably do. They have everything.
There's got to be something.
Everything.
But yeah, so we didn't have time to do it for this Sparkfun Live, but hopefully I'll maybe promise you all that I will do this. We'll print some things on this printer and do terrible things that you should never do with a 3D printer. Yeah. So.
We have
But
another
yeah. So,
audience question
Oh,
from Josh Dacko of Crypto Show.
hey Josh.
He asked, does the open source BB-8 have the GPS speedometer? Also, congrats on that. So if you guys want to talk about that.
Yeah. So Pamela, you know, because we don't get enough work.
Yes.
Yeah. I'll let you talk
Yay.
about BB-8.
Oh, wonderful.
Yeah. Your turn.
My turn, as you just take a small nap.
Yeah.
So we actually have some of the parts here. So we've been using a low spot to make some custom parts for our BB-8 build, and we're doing a fully open source Star Wars drone. And it's pretty awesome. It was on, if you go to make.com, we're featured on there, and we're going to have all the documentation, all the files to 3D print your own, and also how we did it by step. And if anyone doesn't know, I'm not sure if we could pull it up on the computer what actually the BB-8 is. If you've seen the new Star Wars trailer, there is a robot that is pretty much a ball with a head on the top, and that just spins really fast. It's pretty awesome. I recommend checking it out. And so a lot of people the whole community kind of came together and was like, how did they make this? And there's a lot of really great examples on how to make it. Someone from the UK, do you remember what is his name?
I don't know. Sean's been working with him.
Oh, embarrassing. His design was to have a big ball and then have the mechanics on top. So what happens is, I don't know if you want to describe his design a little bit more in detail. All it is that
It's like a balancing robot.
It's more of a balancing robot. Our design is we have magnets and and this is why you should have described it.
No. Well, let's see. Maybe.
Yeah, if you could just pull it up.
Here, don't go to my computer just yet. Let me see if I have a good rendering of.
It's better visually to see it by describing it. But we have pretty much everything inside our main ball. And we have wheels, and we designed it after the Spearow, which the Spearow is pretty much a round ball robot that you can use your you can use your phone to move around. So we just modeled it after that.
I'm digging through all of our pictures.
Casey, hurry!
I know,
Hurry.
it's TV! Where'd it go? Quick, Nick Poole, do something.
The website I said was, make.com. So
Magazine.
Magazine.
I made that. Yeah, I did that this morning. Make.com is nothing.
Oh, it's nothing.
I swear, I have.
Magazine. Makezine, which is a really great magazine. It's been around for a really long time. It showcases tons of hacker maker projects.
Okay, I got a picture on my laptop. Finally, I found it.
A visual.
I don't know what I
So it's
call
easier for me to
anything.
describe.
And I think your friend in the UK was James Brunton.
Yes, that's him. Yes. And his bot is really awesome. Yes. So yeah, we actually are friends at Actobotics. Helped us out with some of the parts. We had some of it from leftover from our Actobotics challenge, and so. But yeah, that's that. But the part that is right here is actually this is what holds the head on. So there's little magnets little casters and yeah. So, but stay tuned for more.
Yes, yes. It's powered by a Spearow and a Raspberry Pi.
Yeah.
All right.
Yeah, you gotta.
You threw me. You threw me in there.
Yeah, yeah.
I wasn't prepared.
More prepared
Actually,
than I am. Look at this.
It's Casey asked me to do the Sparkfun Live with him probably 3 to 4 hours ago. So it's really live, folks.
It's really live.
It's really live.
Okay,
All
so continuing on this mess. So let's get some things out of here. Get out of here. So I don't know if do we have a GoPro?
We don't. I think I'm gonna be holding everything.
Can do
on
a
the
close
camera.
up. So so we're
move
getting
slowly.
really close to being done. So what we have connected so far is essentially all power connections. Hi, Nick. You were on camera for a second. we're just special guest appearance by Nick. So it's like are we big enough to you could be you're cameo now, right?
Yes.
Yeah.
This is a cameo appearance.
Classic Nick.
Classic Nick.
It's a joke we've been trying to get people to be really into is adding classic to our creative technologists and people that are on video a lot. I don't know if it's catching on. It's not catching on.
We'll make it a thing. So, all right. So now I have essentially all the power connections. So now all that's left. So we have our 3 buttons, which are here, and there. We have the power set up for the battery. We have a switch so we can turn it off and on. We have our GPS connected. Lastly, it looks like, so we have one more ground wire, which means there's one more thing, which is
The buzzer?
Yeah, the buzzer. And what's great is I said that I was gonna do something smart, but didn't. So, so what we'll do for the buzzer is, if you could solder this to the negative.
Wonderful.
Yeah, I'm making this really easy for you.
Casey, is the schematic going to be online for people to follow this project?
Yes, I swear.
I don't know if you guys
So-
can see all the wiring,
Yes.
but it's easy
So
to look
there
at the
is
schematic.
a GitHub repo right now that has the code. It has the STL files for the enclosure. But once, I don't even know if this is in fritzing. I'm going to try and get us a fritzing diagram.
That one's in fritzing. Should be
Okay,
in fritzing.
so I'll get us a fritzing diagram for this and the battery circuits. And then hopefully if I can get some time with one, I'll do a step-by-step put together. I have enough parts to build another one. And we'll try to make a hookup guide for that. And definitely possibly a Hackster. So plug those guys because they let me drive their DeLorean for an afternoon, which, thank you guys. That was a lot of fun. That is a very interesting car.
How did it drive?
Interesting.
How did-
It drove.
Drove.
That was the exhaust leak talking.
It's so dry.
It's still, it was an experience. It was like driving a lawn tractor. I think that's the best. It's a very interesting car. I mean, so it was made by a guy named John DeLorean. He made this car company. The guy cut his teeth at Packard Motor Company, and then he went on to General Motors to make the Pontiac GTO, the Firebird, and then he went to Chevrolet. I think he did the Vega, but he like a muscle car mastermind. And then the DeLorean happened, and I don't.
Yeah, not to mention the best car designer of the 20th century.
Yeah, it's an amazing, stylistically, it's a great car, but everything on the inside is terrible. So yeah, it has. I think the picture with Nick in the back, he's like laying on a 3-ring binder. That was actually, they had the whole manual, the entire assembly manual and like the mechanics manual. So of course, first thing all of us engineers are doing, and we're looking through this thing, and the horsepower rating of it, it's 130 horsepower. Like that's out the gate. 130. Like I think my Saturn. I have a little tiny Saturn commuter car. I think it has more power than that. And it's 1,000 pounds lighter.
Sad part is I haven't seen Back to the Future. Haven't seen it. I know.
What?
Why am I here? Why?
And this, yeah, well, that's it.
Live is over. It's over.
And that's it. So, we'll have to press on. So,
how will we make it?
Yeah, how are we gonna do this now? So,
so I literally just soldered jumper wire with the female header side on the ground.
Yep.
On the
So you can connect that to there. All right. So now we got to get these buttons interfaced into the display. So what I'm doing is, give me a minute before I get online.
Practice internet safety, folks.
Yeah. Okay, so if we go back to the site, we have the 7-segment display here, and if we'll look at this picture here on the back side. So this RX pin, this is what we're using for the GPS input. VCC we're using for power. We have our ground. But to use the buttons, what we're actually going to use are, for the buttons and the speaker, we are using the slave select pin, the serial data in, the clock line, and we are using SDO, so serial data out. So what do those mean? All right, let's go to the data sheet. Well, our schematic. So here we have our schematic. Is that too blurry? Okay, we got it there. So there's our slave select. We actually call it MOSI because it's actually part of the SPI port on the Atmel. I believe, yeah, we skipped the reset because you don't want to tie anything to reset. That's an exciting mistake to make. The clock line, and then MISO, so that's master and slave out for the SPI line. So, okay, what do those mean in Arduino? Because here's the best that we get with this schematic. Let's see if I can zoom out a little bit. So over here, those lines are connected up to MOSI, slave select, MISO, and the clock lines. So if you Google Arduino pin header, pin out, there's this really great infographic that pops up. I wish I knew marcusjenkins.com. You're great. So what this does is this shows you all of those pin names. So over here, like, let's see, we're looking for slave select. And so we found it here. And so what that is that shows us that's a PWM line, that's, it's an interrupt, it's part of an oscillator or a counter. But more importantly, it's pin 10 in Arduino. So slave select is pin 10, MOSI is 11, MISO is 12, and the clock is 13. So that's the little blink LED, the pin 13. So that comes in handy when I go to the code here. So what I did is I tried to assign them here. So I use pound defines a lot to kind of just essentially, instead of having to remember like which pin is which, I just make a pound define and do that. So you're more of a code person, so don't look at this too closely. But
that is beautiful.
It kind of works. So what I've done is, so the settings button is 10, which actually, while I'm here, I might as well comment, because that's...
Comedy is important in code.
So
Why is it important in code, Pamela?
yeah,
Well, Tony,
When she has
comments
to
are important because you'll write code and probably 10 years down the road, if the code still works, you'll look back at it and wonder what you did. And instead of spending forever trying to figure out what you did, the code, you'll know exactly what's happening. Thank you, Tony.
losing my mind. Where is so pin 10?
There's a reason why Tony heads this. She knows the important questions.
I threw, yeah, there. So, and actually, if you would like to, there should be a bunch of green wires in the mess. No, there isn't. I lied. I'm a liar. Let's try blue. So, if you take the female ends of the blue wires, what we'll do is 3 of those will go. I'm gonna cheat and look ahead. 3 of those, so we'll put, so the buttons are gonna be on slave select, SDI, and SDO. So the clock line is actually gonna be the buzzer. So if we just use a different color for that, we'll make that work. So down button, 11.
Does the gnome have a name?
No. I don't. That's.
The gnome is a little scary over there, just bobbing away.
Isn't he
And
great?
I feel like he's
It's funny
looking
because
more and
as
more over here.
As he bumps into the top, he starts like turning his head.
It's
So, yeah. So that's the gnome from the BattleBot. Because my robot's name is Electric Lawn Gnome Supremacy. Because that happened. Yeah.
Casey, while you're doing that, you've done a lot of things with BattleBots and just battle robots.
Yeah.
How do you feel about the new BattleBots show on ABC?
I like it. Yeah, it's cool that it's like, how does the gnome feel? So but no, I like it. If you guys haven't seen it, it's on, I think, ABC. It's, I don't know,
It's
8,
so creepy.
9. Oh.
It's so creepy, guys.
That's brutal. But it's on at 9 p.m. I think, 9 or 8. It's on Sunday nights. It's really cool. They're kind of, I think they're doing it better justice than Comedy Central did. Like, it was like 10 years ago. So yeah, they're trying to do more of the backstories on the builders and, you know, try to you know, I don't know, make it more approachable. So, but at ABC we had 1 and 3 pound combats. So, I mean, these big machines, the ones that were on TV were 250 pounds each.
Jeez.
So that's a lot to move. So the 1 and 3 pounders, it's kind of nice because, you know, it's not a huge investment. You know, you're not buying hundreds of pounds of steel. You know, you can kind of build them, you know, in a few weekends. You know, you can travel with it. That's cool. Like, traveling with a huge robot is a pain because you got to ship it. Like, UPS won't touch it. So, 1 and 3 pounders, it's cool. We're hopefully going to have them next year at ABC, and maybe do another event or two. So, but yeah, if you guys are interested, we'll try to do something. Say what? Oh yeah, we have our arena. Marshall, I saw him walking by. Marshall is awesome. He helped wire up the entire thing. So there's like buttons that tell you when you're ready. There's tap out buttons. There's lights. There's a timer up top. The judges have all kinds of buttons to do. They can pause the match. They can start the match. There's 2 hazards in the corner. But we stayed up every night, all the nights before ABC, and it was a great event. We had, I want to say, 20 robots show up, which I was absolutely blown away. There was some really great robots, really great robot names. There was Lolly Chop. It was a father-son team, great guys. There was the Hopeful Narwhal 3, which means that there was a 2 and a 1. So, like, that's awesome. And then there was there's actually a whole bunch of marks in the floor. That was from a robot called the Ugly Weasel. And it's made by our friends at Modular Robotics just down the road. And they had a blast. So, but I think it turned out well. I think the competitors enjoyed it. So it looked like there were people interested in it. So.
Yeah. What did you use for the obstacles in the corner of the arena?
That's a saw blade. So that's a saw blade attached to an electric bike motor. So, yeah.
Slightly deadly, just slightly.
Slightly. So it's more of a nuisance. So, man, we're almost
Cruising along.
we might make it. What is the movie? We're gonna make it. Right before the shark.
Oh no.
So, you got this covered. This thing might actually finish printing on cue. Maybe. How much time do we have left? About half an hour. Oh yeah. Yeah, Mike, do you want to show, we got a time lapse of, I believe, making this guy. I don't know which camera. This camera. That camera. Hi, camera. So I think we have a little time lapse of this. So it's, I had it set up in my house for a while. Yeah, there it goes. And yeah, this print, I want to say took like 6 hours, but just a GoPro, and I think taking a frame every 5 seconds. So it's kind of cool to see it just slowly grow the part.
So for back to BattleBots, or your the combat bots, the blades that were spinning, was the blade bent a little bit before the competition? Or did it destroy a robot and that's why it's a little bent? So
we ended up bending it. There's a bunch of little teeth on the blades. They're all gone. There's a few teeth that are bent up. These little ant weights, there's a lot of power in them. But now that was, we tried to drill a hole in a bolt to, yeah, I don't know if you can see it. It's the far back corner one. But we tried to drill a hole in a bolt to make it fit, so they're actually just bolted down. And our drilling skills are not that great.
Oh, okay.
So it came at a huge angle, so it was really lopsided. And so the day of, I think I had Pete. Pete was helping. I've never seen Pete more happy to just like solder things together or just like build something. So Pete is definitely an engineer at heart. Yeah, we were just like, how are we gonna fix this? And we're talking like it's like 30 minutes before we're supposed to. We're already like, I think we started an hour late.
Oh no.
And so Pete just go bend this or something. And so he ran off with a saw blade, which he might have had safety glasses. I don't know. So
but don't worry, we have safety goggles for soldering. Not working with blades. No. So, but yeah. Awesome. Are we? So we just hook up all the buttons and the.
Yeah. So let's see. What do we have left? So slate select. So this, it's going to be the clock. this one is going to be connected to the buzzer. Hopefully there's enough room. We're kind of winging it, so we'll see. I know I wanted to use this it might finish. We'll use this one, and we'll go ahead and use this one. So I'll only be mostly disappointed in the printer. Faster. So
we can blame the gnome.
yeah, the gnome is really.
It's adding so much weight to it that slowing down the printing. So.
Yeah. Okay, moving on. So it looks like everything is connected. So actually, before we stuff everything in the enclosure, let's go ahead and just see if it works. So if you want to connect up the rest of the buttons, the order of them, we'll figure it out. And while that's going on, I will try to get our FTDI, which I didn't know everything about, ready. So that should be good. The only downside with this printer is it uses the same style of USB to serial as the FTDI, so every once in a while, if I'm programming an Arduino, this will pause or it will like completely stop. So if you're doing like a 6-hour print, it's mildly terrifying, but I think we'll be good. So oh, it finished! It finished! It worked! It worked! So, yeah, so it's done. And look at it. It like presents it to you. It's like, look what I made.
Zoom in of the gnome.
Of the gnome. Look at him. He's so, look at, the gnome is so satisfied right now. So, yeah, so the first thing you always want to do is like just grab it. With this HIPS high impact polystyrene, it's still a little bit squishy. So right now the printer bed is cooling down. I'll just go ahead and unplug it so no ambiguity. So there's this base on it. So they finally figured it out, I think. It's like a special plastic, and when it cools, it actually contracts and pops it loose.
Nice.
So like it's still kind of
nice improvement.
Yes, it's stuck to the base right now, but as it cools off, it'll work. So yeah. So you've got everything wired up.
Test it.
I got an FTDI. If you want to go ahead and plug that into that, we'll see if it just turns on. Smoke test. We're doing it live. See how it does. Does it look like is it the front? Look at the front. Is it doing things? Okay, cool. It works. Okay,
we're done.
I planned it like that. I swear. Okay, so do we get a shot of that? Okay, so right now, if you look at it, this has the original firmware. Let's see.
No.
Yeah, so the original firmware. Okay, so you see all that garbage going across? It's garbage.
You didn't program it that way? You didn't program it to do garbage?
So what that is the serial 7 segment is designed to just take serial data and just print it. So the idea is that if you want to print 4 numbers, you send 4 numbers, and it just prints it on the display out of the box. So it works. So what it's doing is the strings of the GPS are being dumped into it, and so it's just trying to print that on the screen, and it comes up as just garbage. So we're going to turn that garbage into something meaningful. So I am going to try to just program. Let's see if it just does it. Oh, and actually, so the thing is that remember when I said we have to be able to disconnect the GPS? Because they share the same lines. Ooh, thunder.
If you didn't hear that, that was thunder outside, so we have nice sound effects.
Okay, let's see if I can.
It's going to program. We took the GPS off, unhooked.
Yeah. See if it'll find it. All right, there we go. We have USB serial. And hopefully, Is it blinking? You might be able to see the FTDI. Oh, there we go. So we have blinking, so it is doing something with firmware. What does it look like now?
Yay!
Okay, so if let's see if we can show the camera. So right now it is showing lines. Okay, so that's part of the program, I swear. So what that means is it has no valid GPS signal. So what we'll do is now unplug the FTDI. So that's going to shut the power off. So I have a freshly charged battery.
Nice.
We can test the switch.
So I'm just plugging this into the LiPo charger, and then we can go ahead and add the GPS unit again.
That's great because we get just plug things in. Who doesn't like that?
So I just turn the rocker switch on. It's still trying to get unlocked.
Yeah, so we might be able to show this. I think I've had this one on. This one might have died on us in the.
Please switch batteries.
So, so this one I'll try to see if I can get USB. So actually, I'll switch batteries on this one. I have another battery. I need another battery. Stat.
Battery?
Oh,
Battery?
there we go. I have one charging off camera. So.
That's the first thing he was prepared on.
I was like,
prepared on for this video.
I just needed to at least work once.
Yes.
So, so let's get that in there, maybe. I'm now discovering all of the problems with my enclosure. So, so this is going, and because it's charged up, I'm gonna disappear off frame and see what I didn't do right.
You want to take this one and disappear off frame?
You're not really off frame.
Let me think about it. I'm never off.
No.
They'll always find me. Is that gonna stay?
Looks like it.
Okay. So what I'm gonna do is, if this will stay alive, I'm gonna walk out into a thunderstorm that is slowly approaching and see if this will get us a GPS lock. So
I'm going to sit here awkwardly and also name some more. Earlier I was talking about Casey's blog post on, it's called Just Because You Can Doesn't Mean You Should. And I recommend checking it out because it's a list of all the things that community members came in and suggested for 3D printing that's completely useless. I thought it was going to take longer than that. I was going to name.
Keep going. It's still thinking.
5 minutes. It's going to take about 5 minutes. So I'm listing.
We haven't even shown the DeLorean video?
Oh.
Great Scott!
Maybe we should do that. Mike, roll it. Roll it.
Just throw everything all at once.
Yeah.
You talk about one thing, I'll talk about another thing. We'll get Nick Poole on camera.
It'll be great.
We'll get a cameo.
Beautiful.
Yeah, so that shot is Nick. That's Nick Bingham just crammed in the back of the DeLorean. And we are trying desperately to get this thing up to 88 kilometers an hour. It's 55. We had to do it downhill.
It makes it better to go into the future, right? When
exactly. Yeah, went through it. Yay! And then I'm like, oh, now I'm speeding. But yeah, so yeah, we'll show you all those fancy buttons. It's gonna be great.
All right.
And most importantly, coming up.
What a race!
Oh.
That's the window. That's the window in a DeLorean.
Oh my God.
So it's incredible. It's so tiny. And look at it. Yeah, this car is not.
How do we know know that Nick is not just a huge, huge, huge man. He could just back to us. I'm sorry. I'm sorry. I'm sorry, Nick.
Nick and
It's, I wasn't calling you huge. I was,
He was worried you were in
yeah.
I'm calling him a large person. That's what Nick was worried about.
Nothing wrong with that.
oh. How much time we got left? Right as this thunderstorm is absolutely going to roll in. So, is that CJ? Yeah. So, yeah, it's
Talking
out there
about
just
how tall you
sad.
were.
Oh, cool. You can see it.
Yeah.
Great. Nice. So, that unit, you'll notice is much brighter than the unit that we have on our desk. I did a hack on that one to make it work great for television, which I'll show you on my computer what I did. So there are little resistors, so current limiting resistors for the LED segments. And essentially what I did was disabled all of them. So that LED display is running very hot. But essentially if you look on the back, so on the back of the unit, so this resistor, this one, this one, this one, this one, this one, this one, and this one. Essentially all the resistors except this one. Don't remove that one. Remove all these and just put little solder blobs across them and you will have a super bright display. The only one I tested this with is the green display. So that's as far as my warranty's going.
Yeah.
So, but yeah.
That make a difference with different colors.
Yeah. So
Tony asked, why would that make a difference with different colors?
How much time do we have left?
Yeah.
So, actually, let me see if this one is different. It looks like they're very similar. So each LED color has a bias voltage, like if they call a forward voltage drop. So I believe red LEDs have the lowest and blue LEDs have the highest. Fact check me. The internet will fact check me, I'm sure. But essentially it comes down to the different chemistries and how they make the diodes. That's what determines the forward diode drop, which essentially like if you have a forward diode drop of 3 volts, it takes 3 volts to reach the illumination current. And then there's a whole bunch, what am I trying to think? There's math. There's math behind this. You need to be above that voltage, but as soon as you're above that voltage, the diode functions, and then you have to calculate the current to illuminate the LED. So we have a tutorial. I'm gonna
Really
throw this
good
back
tutorial.
at Tony, and I think we have a tutorial. So, but yeah, I'm mixing up the actual equations of just figuring it out and then like the actual like chemistry of it. But
I have another question for you.
yeah,
Audience asks, can a big gulp fit in the cup holder of the DeLorean?
was there even were there cup holders?
Wait.
There's a shot of video we just watched of you shifting.
I don't think there's even a cup holder in it.
What?
I don't think there is.
I mean, the DeLorean, why do you need a cup holder? You're driving a DeLorean to your personal Learjet. Yeah, you don't.
Yeah.
Yeah. So, yeah, I mean.
Would your drink still be good when time traveling though?
I
mean, would your pop be flat?
So what if you left, okay.
But you're in the vehicle. I
I
haven't seen the movie, so I don't know if you're in the vehicle, you stay, like your pop will stay fine.
What if you left?
These are fair questions, because it might be the reason why they're not having a cup holder.
We're gonna have to watch the movie and educate. But the question would be, so a time traveling DeLorean. So the famous like if you leave your drink on your roof.
Yeah.
Would it be in the same time or would it
That's a better
age?
question.
Because inside the DeLorean,
Nothing.
Yeah. But if it's on top, so if you left like a glass of scotch or something, would it be finely aged scotch or like?
Science.
Could you go back?
Science.
Or, I mean, these are the questions that we need to be asking. So, but okay, back to this.
You forgot we're building something.
Yeah. All right. So now we have everything together. It's kind of working. Is the one outside working? We'll see.
Stop raining. You can go. Go for it.
Hey, little buddy. What is
You
it?
want to see it?
Oh, hey, it's working.
Nice.
Okay, so it's not moving, so it's reading 0 miles an hour, or I think it's kilometers. These are set in kilometers right now. Yes, thank you for that, Mike. So that one works. So we proved that at least one of these devices does work. But what we're going to do is we're going to take ours now and cram it into the box. So the easiest thing to do is to probably start, actually we have a hot glue gun running somewhere. It's over there, is it?
Yep.
So actually before even that, I want to make sure, so 3D printing the holes, which it's awesome that it can actually make those, but the problem is sometimes when you size a hole, just due to the plastic, it doesn't quite want to fit perfectly. So you either undersize the holes and drill them out, or you oversize the holes. So actually, I pre-drilled this one. So if I pop, let's see if this one will just pops right off. So here's the new one. So as you can see, the holes don't quite fit. So that's what the drill is for. Hand me the drill, or if you want to try to do this. So. So to drill these, here I'll show you how to do one of these. Oh yeah, safety glasses. Almost died. Put the "do not try this at home" on there.
Yes. Oh, did you have a black screen? Like,
we just need a cutscene to just me with a drill in my eye or something. So one of the challenges of drilling through a 3D printed material is because it's laminated, everything's laminated. It's prone to splitting. So it's kind of like working with wood. So you can split wood. You can split 3D printed parts. So to do this, we're gonna see if I'm gonna break this, but just slowly go through, and like that cleans out the hole. So some people will they won't even make the hole. They'll just leave a solid material and just drill the holes afterwards. The Lulz Mini is actually made from 3D printed parts itself. So you can actually recreate parts of the extruder and some of the upper elements. And how they actually screw things together is they have these like brass threaded inserts that they solder. They use a soldering iron and just like melt them into the side.
nice.
So yeah, it works well. So cool. So now that's ready.
Add the buttons.
Yeah. So there's little nuts on the front that will hold them. So we pull all those off.
See, I'm just
Yeah. I've got another one of those.
Just taking the nut off.
So there's a little, let me see if I can do this. And it's gone. So there's, with each button, I'm gonna try not to move. With each button, we have the button itself, and then this is a lock washer, which tries to keep the nut from spinning off, but then the nut. So what you do is you'll drill a hole, push the switch through, and then use the nut to hold it against the face of your enclosure. So yeah, that's that. I'll try to clean up while this is going on. Is it going through? Oh, you don't need the lock washer, actually. I'm sorry. You don't need the lock washer because we're going to just bathe it in hot glue.
So what does all these buttons do? What's the green versus the two red ones?
So I thought, while making this, so I drive, I have a really old car that I've been working on, and the speedometer in it's just garbage. But an interesting thing I thought of was, since I wasn't quite brave enough to directly put a servo and put cruise control on it, because driving it back and forth between my folks' house, it's like a 4-hour drive there in southern Colorado, and so cruise control that I make is probably not safe. But so I have a tendency, depending on the time of day, to either speed up to rocket ship speed and just kind of keep going, or I am that person that slowly slows down to 55 on the highway. I'm sorry. So what I did is I put the buzzer. The buzzer is going to have two tones. So there's a low tone for if you're going too slow, and then there's a high tone if you're going too fast. So it's kind of like an audible like cruise control. So you can, as you're driving along, if you hear a little beep, you either know you're too fast or too slow. So and what the buttons do is when we get it working, the buttons are actually what sets that speed.
Okay.
But if people want to build these and hack them to do other things, like I'm sure there's all kinds of settings that you can do. You can. I think there's a few extra GPIO still that you can. I don't know. Make this thing do whatever. I still want to try to do a cruise control. So I'm just waiting for somebody to be brave enough to let me use their car. I mean, I'd use mine, maybe. But yeah, just a servo cruise. How hard could it be?
We do have an RV.
We do have the RV.
Do you want to test that on an RV?
I don't know if I even want to drive the RV. So we could recreate speed. It can't go below 55 because it won't shut off.
You can't. So,
yeah. So
we'll watch you.
Yeah, from a distance, from the police helicopters. So cool. So you got the buttons in there.
Yeah. This one's a little. There we go.
Yeah, they're a little. We're doing it live.
Yeah.
I'm gonna use that as an excuse for everything now. Every meeting now. We're doing it live.
And since all this stuff is open source, like the enclosure, and Casey's gonna be posting it, you can take it and make a better enclosure if you want. But I mean, I'm not saying this is perfection right here. But if you wanted to add more buttons or anything else, you can very easily.
That's great. That's great. That's great. So, so now that we have the push buttons in, let's go ahead and see if we can actually stuff the buzzer. And I just realized is we're probably gonna have to disconnect the switch because the switch has to go in before, which is why, see, these are smart. These are smart. I would have soldered those together, and at the end of the show, I would have been like, well, you're on your own. So, but awesome. Yeah, that'll work great.
So we have an audience member that says they'd rather just stick with their Android app for a speedometer type thing.
Well, then how are you going to text and drive?
I will be. Please don't text and drive.
Yeah, Nick's got some cool. Oh, that's awesome.
Oh. That's a Mike Gruesome joint right there.
Yeah.
Oh, that's awesome, Mike. Oh, Evan.
Oh, yeah.
Our mechanic.
Sorry for the misattribution. I just thought that might be appropriate given the discussion.
Yeah.
Perfect timing.
Yeah, I think it's using
see
EL. Is it? Can you guys see it moving? It's actually
chasing EL wire.
Yeah, it's got some. So no, but so the Android. Okay, so Android's cool. I like it. I don't like taking. I honestly don't like setting my phone up on the dash. It's just a weird thing.
Overheating too, just with the sun.
Yeah, just like
Coming down.
running. It's nice because like, you know, one of these little units, if you just leave the USB plugged in to a battery, if you run on the accessory line, you know, you can just leave it in the dash and just, you know, don't think about it. It's just a part of your car now. This is also great for like a bicycle, you know, like I've actually run around the parking lot with this and tried to see how fast I am. It's a terrible idea. But I don't know, and it's kind of an interesting thing to build. It gives you kind of, you know, some use of GPS and, you know, so if you want to use your Android phone, cool. If not, there's this.
Well, other question is, how long will this LiPo battery? This is 1,000
Yeah,
amp
so
hours?
the battery, I kind of thought that the GPS was going to consume a lot of power. I actually did the very first one of these I built. I lost it because I put it in someone's car and they like drove off with it.
You should have
Yeah.
should be a tracker. Have it come back to your.
So
to you.
when I was testing it, I was actually able to get about a day and a half of battery. So I for testing, I actually set it in my car, and I just turned it on and let it go, and I drove to work a few days, and I found that I could get about a day and a half of battery. I'm sure that, you know, if you had something in there detecting, you know, if you're not moving for so long, it just shuts off, but that's for the user to decide. So you guys try to figure out how to make it low power. So, but yeah.
All right.
Cool.
That
So I'll help you reconnect some of these. So we'll get all the switches connected back to ground. This one's, get the chaos sorted. What's great is that when the enclosure with the lid, you can just mash it all back in there. And then
What kind of plastic are you printing with?
this is HIPS, so high impact polystyrene. I know the printer is really good with ABS as well. I'm missing a lead from somewhere. Or did we just have an extra? So this one goes here. And oh yeah, there's the buzzer. So now everything's connected. Let's go ahead and I'll try to power it on real quick. Okay, so it's on, it works. So the buzzer, this is kind of where it gets into the gymnastics of putting it all together. So the buzzer has, so there's our other enclosure. So the buzzer has like a little slot. Here's another buzzer.
So you can see that there's this little slot right here. I'm not sure.
Very good. There's a buzzer if you want to stuff it in there.
Side of the enclosure.
Oh yeah, sure.
Camera.
Yeah, and we're done with the iron, so.
This little slot right here.
Turn it off.
You can actually go ahead and works perfect to put the buzzard in there.
So, and then the hot glue gun. So because there's a little USB charger, plugging in the charger, I couldn't quite make a good enough clip with the 3D printer in this short amount of time. So what I'm gonna do is, I just have that real quick. So what I'm gonna do is just kind of shoot. What's awesome about HIPS is it remelts. So as soon as you put hot glue on it, it actually kind of mixes together a little bit. It makes it kind of a cool mess. So, so I just put a little bit of hot glue in there. It's still pretty hot. And then I'm just gonna take this, kind of stuff it down in there, just push it down as hard as I can and let it dry. So hot glue is coming up through the little center hole. Let me put a little blob on top.
So we had a user say, don't print in PLA, it will melt on the dash. Did you have that problem with this in the heat?
I did not. Like, you know, It hasn't been that hot recently, so I guess I haven't tried that. I guess PLA would. I think the turtle here, Harold. I'm gonna name him Harold now. I think this is PLA, and then hips. Huh? Mitch McConnell. Okay. Harold. So PLA, it's a corn based, if I'm not mistaken. This is kind of the bread and butter for a lot of 3D printers. I know that we sell ABS. I believe we sell ABS and NinjaFlex on the site, but there's plenty other places you can get all kinds of 3D printer filaments. I've seen stuff that has like stainless steel embedded in it, iron.
Wood.
Yeah, there's like a wood, simulated wood. I think if a good observation would be probably to make this out of ABS if I was doing this more of a long-term solution. So looks like everything's in there.
Let's see the little. I'll try not to shake.
So our little
the
USB.
Hole, the USB, and then see inside.
Maybe if you tilt maybe that way, I don't know. There we go. Yeah, so there's just a little bit of hot glue it's from the inside. It came up through the hole, and then I put a little on the top, and that's, I kind of call that the hot glue rivet. But hot glue doesn't take long to dry. It's great. If it's really bad, you can always pop it apart, or you can use if you have a heaterizer, you can use a heaterizer to kind of get it a little melty again. Yeah, we stuff that. Let's see if we can just cram all the wires in there, or we'll put the battery in last. The GPS actually will ride right in there like that.
Let's see.
This is very, very scientific. Look at that! Look at that! All right, get the lid.
Wait, no. So you can see that stuck the GPS on this side.
So you need to make sure that the GPS antenna, this little ceramic bit, needs to be pointed up, because that's where the satellites are for GPS. So make sure that's pointing up. Let's see. All right, yeah. So the trick is you just kind of quickly slam it together.
That's a trick? I like it.
Fluff. So, and we tried to make little latches so it'll kind of snap together maybe. Let's see.
Nice.
Did it do it?
Yes.
Look at that. All right, now turn it on and see if it works. Does it turn on? Is it on?
It is on.
Oh, great. Well, so it's doing its thing. So here's what I'm going to try to do. I'm going to try and put this one out in the thunderstorm, and I'll go get the other one. We'll see if this one will take a lock. So, and then I think you guys can still hear me because I have a microphone. So I have this, and I'm out in the thunderstorm, and now that I'm moving a little bit, I don't know if you guys can zoom in. I'm going to try and hold it as still as I can. It thinks I'm doing 100 kilometers an hour, so the storm is really messing with it. And I'm going to try and get it really close if you can hear the beeping. Oh, of course not now. But the low beep means I'm going too slow. If I hold this button, it tells me how fast I should be going. So that's 55. And then, yeah, so it'll update its rate. In theory, if I walk towards you, this is in kilometers, it should go up. Nope, it's not going to do it. So, all right, well, I'll bring it inside. You can hear it making its lovely.
Yeah, the beeping.
So, but now that we're inside, of course, we lose our GPS lock. So it might catch it a few times. So we're in a nice big metal building. But is it safe to take our glasses off?
Mike, can we take our glasses off?
Might be. the lid is off, so
It's just gonna pop out the button.
It could attack. So it could attack at any moment. So, as you can see, I iterated on this design a little bit. So this is the first lid that we made, or not? Oh, this is the second lid. So this is kind of the version 2. Of course, before that, when I thought it was awesome, I tried to make this enclosure. This was a miserable failure. This is when I forgot like how big parts were. So I just like put holes and I was like, oh, the button will go there, and then the screen will go there, and then nothing fit. So, but what's cool about a 3D printer, I mean, this spool that I have is 1 kilogram, and the parts that you see here, I think I've printed a total of 5 of these with different iterations. And I'm still working off 1 spool, so 1 kilogram actually goes a long way. So what's cool is it's great to design everything in CAD. If you're really good, you can design everything before you even touch it. But I'm kind of that halfway in between. I like to design things in the computer, but I also just kind of like to play with the shapes. So printing out a quick rough draft, at least gives you an idea of what's going on. So
Definitely.
But yeah, we'll have the code up on GitHub. I guess if we want to go through that, I didn't even go through the code.
Who needs code?
Yeah. Let's see. Yeah. Okay. Well, I'll give a quick shout out at least to Tiny GPS. So this is powered by Tiny GPS, written by a guy, Michael Hart. That one doesn't actually stay closed.
Okay. Just put it down.
That's why it's V2, not V3.
Okay.
Michael Hart, really cool guy. Got to meet him once. He wrote Tiny GPS. I think he wrote softwares? No, he didn't. Yeah, he wrote Soft Serial, but his library is incredible. Essentially, all you have to do is tell it, this is where the GPS device is, this is how fast it's talking, and then you do a function call that says, how fast am I going? And that's it. Like, it's wonderful. So, but if you dig through the code, I'm gonna try and I'll comment some more, but clean it up a little bit. But I posted what I have, what you saw here, and yeah. So. Now
any
what?
Questions?
Yeah.
Anyone has any questions?
What do I do with my?
I don't know. Look how clean this table is. What are we gonna do?
Still
Cleaner than your office.
Yeah, cleaner than my office. We should just have a camera in my office. It's just, it's like the pandas. So just.
I already kind of did.
Just swooping on. God. So is our unit outside alive? I don't know if see what we can see through the camera, but I'll go out there. I'll go out and check on it. So
You have the button turned towards us. Yeah.
we can. Oh, did it's not even facing you. Great, guys, it's totally working. I swear. So hey, it actually works. So this one, as you can see, it's a lot dimmer, but it is actually doing its thing. So cool. Well, it actually works, and it thinks I'm doing 5 kilometers an hour. Great.
You're not surprised that it actually works. You're just.
I'm so happy. So, but I think the buttons are doing a little weird. But so, well, cool. Yeah. I made something that worked, and I did it live.
It really happened. Yay, victory!
And it's not 3:30 in the morning. So, like,
that's the best time to get projects done. Around 4 a.m. or 10 minutes before you have to be at work.
See, I find procrastination, if you just wait till the last hour, you get it done in the last hour. It's efficiency. So, cool. Well,
Sweet.
is that all we got? We got any more footage? That's it? All right. Do the DeLorean again?
Yeah.
Play us up. So yeah, with that, thank you so much for the help.
Oh, well, thank you for inviting me, Casey.
Yeah.
Wonderful project.
Yeah, thanks for jumping at the last minute. Thanks to everybody else who's been behind the scenes here. So with that, thanks again. We'll have another Sparkfun Live in some time in the future, but we'll announce it next month. We'll announce it. We'll have another wish list up if you want to build the project, and yeah, they'll be more prepared than I was. So
Impossible.
yeah. Thanks again, and see you next time.
Bye.
Hey, am I done? Logan.